Hey everybody, welcome back to the Automation Show. Shawn here from Insights, and for the last several weeks I've been working with Schneider Electric to cover their new Modicon Edge I/O NTS system. I've had meetings with them where we've gone over all the technical specifications, and they've actually sent me in a box of their hardware. Let's go ahead and take a look at it here, and I will switch over to the overhead cam, and here we can see this huge box of their new Edge I/O NTS system. And I want to say something before we go any further. And I wanted to say that a video like this would not be possible without partnering with the vendor. And not only did Schneider sit with me on multiple occasions to educate me on this new product line, they actually sent me this box of samples, and they sponsored this episode to make it ad-free so I could afford to spend the time to unbox it, wire it up, and connect it to Compact and CompactLogix. Yes, I said that right. Schneider already has plenty of videos on how to connect this to Modicon. They wanted me to show you how to connect their Modicon Edge I/O NTS system to Compact and CompactLogix over Ethernet IP, and I'm kind of excited to do that. So with that said, let me go ahead and get all these items out of the box, get them on the table. We'll unbox some of the major components, take a look at them, then I'll assemble them together. We'll wire them. I'll do a time lapse of that so you don't have to watch me wire every wire. And then we'll see about getting them to communicate to Rockwell, Allen Bradley, Compact, and CompactLogix. All right, guys, I got everything out of the box and got them on the workbench. And this is my first time looking at the physical items. I've seen lots of slides, but this is my first time looking at them. And their part numbers are very interesting. I think they're very easy to use. And I'll put a slide up on the screen that shows you how they work. But they all start with NTS. So this is Edge I/O NTS. So that's very helpful. And the next three letters determine what the product is. So if it's a DVI, that's a digital DC input. If it's an NEC, that's a network Ethernet communication module. So let's see if I get this right. We'll open this guy up and see what's inside there. Okay. All right. And yeah, this is your main network connection. Let me get the remote here and we will zoom in and take a closer look at this guy. Okay. So to start, we have this 2-port switch, Modbus TCP and Ethernet IP, which is so awesome, having both protocols. We also have a USB-C, so maybe you don't know what the IP address is. You can plug in that way and configure it. We also have the MAC address right here on the front, very easy to find, and that's very important. We'll see more about that later. We also have the 1s and 10s for the name, and then you'll notice on that switch there, you'll see an option to clear the IP, to use the stored IP, or to use BootP. Now, I did learn a couple of new things from a recent meeting with Schneider, and the first is that even though when I unboxed this, you didn't see any end cap or what they call a cluster termination or terminator, when you buy this, it does come with that termination. So you'll see an extra module off to the side here that terminates your cluster of I/O. And that's important. You can't actually use the NIM without that terminator. So I think it makes sense that in actual production units, you'll get that in the box as well. We'll see it. I'll show it a little bit later here in the video. But in any case, I did want to let you know that you will have that included when you buy your network interface module. The second thing I want to talk about is that the Clear IP label you see on my unit, that's actually been renamed to just Clear. It clears more than the IP address. So they wanted to be more clear with the naming of that position. So they just, instead of labeling it Clear IP, they labeled it Clear. So that's another difference you will see in an actual production unit versus the sample I received. Okay. Of course, you can see the QR code on the front, and then you can see the indicator lights right there. RON, EVER, IO, MNS, etc. Okay, let's take a look at the side here. Okay, got the model number there. I like that the model numbers are, or part numbers are, so easy and simple to understand. Okay. And on this side, okay, you can see that information right there. And now I want to show you the latches here. So if you see here, they not just close the DIN rail, release, lock, but you can also see it locks in the latches from the modules to the left. Okay, and here's the hooks or latches. You can see them right here. Okay. So I know it's not a totally unique design, but I like it because it means you get this positive connection pulling the two items together. Okay, so this is our head module, or our NIM, Network Interface Module. Okay, so I'm going to put that one aside. So the next module I want to unbox is the one where we wire up power. Okay, power both for the field bus and for the electronics, and that happens to be this guy right here. I cheated and I looked first, but in any case, let's go back to the overhead camera. And you can see it right there. NTS, again, that's the product. PFB. Okay, so that's the power supply module. Okay, let's go ahead and open it up. Okay. Put it over to the side there, and let's take a look at the front. Now I don't have the terminal blocks in yet, but you can see at the top it says bus and field. Okay, and if we get closer here, we can see the top one is for the NIM and bus power, and the bottom one is for your field power. Okay, right hand side, and we can see those latches there, and PFB. So you're always going to have one of these, and if I understand correctly, this will always be directly to the right hand side of the NIM, the network interface module, or the head. Okay, and again, release, latch. Okay, let's put that one aside. Okay, next let's open up some I/O. I'm going to do the DDI. This is the digital DC input. Okay, Modicon Edge I/O NTS. So let's open this guy. And they don't come with the terminal blocks because they support both spring and screw terminal blocks. And you can get the terminal blocks with and without covers as well. But if we come in closer here, you can see all the actual inputs. You can see if there's any errors. Okay. You can see the wiring diagram. Now you'll notice this is actually two different parts here. We have this base, and then we have the I/O module, and that's so that, you know, if you wanted to replace one, you know, hot swap it, you can. The system does support that. So one of the things we'll see is if we come back out here and look at the box, you see that K at the end? That means this is a kit. This has both the module and the base. Now, if you had to replace a module, not that it would go bad, but who knows, you wouldn't have to buy the K because you already have a base installed. You could just buy the module itself. But in any case, I think most new applications, you're always going to buy the K because you're going to need both pieces to have a working system. Okay. And these, how do they come apart? Well, you see this little green button here? You just press it in, and they come off like that. Very, very simple, easy, and I think intuitive design. And that's the first time I did it too, so very easy. Okay, so let's put that digital input over to the side here. And where is the digital output? Okay, again, I love the catalog number, part number, NTS DDO, digital DC output. Okay, so let's open that guy up. I'm sure this looks very similar to the one we just looked at. Okay, see, this is an 8-point. All right. Okay, and now notice how this one's longer than the previous one. Okay, so there's different modules, different designs. Some will be a little bit longer than others. They even have models where the terminal strip can be side by side. But with that, let's go ahead and open up this mod. This looks like a DDI 16. Okay, and again, it's a kit, ends in K. Get this guy open. And we'll see what a 16-point module looks like. See, it's a side-by-side configuration. All right. And if I remember correctly, that means you'll have 2 wires per. Okay, let's look at the terminal block listing here. You can see there DI1, DI9, DI2, DI10, and so on. Very easy to understand wiring label. I like that it's not ultra small either. Some products, they have such tiny rating on it that as you get older, they can be a little bit of a challenge to read. Okay. It feels very sturdy, not flimsy. You know, some products I've felt over the years, they feel very flimsy. These actually feel very sturdy. So that's always a good thing. You know, when you feel like it's going to break if you drop it, that's not a good feeling. What do we have here? This is an EHC. Okay. High-speed counter 1. You see it right there? HC must be high-speed counter. Very interesting. It also says there's some DIs and DOs on there. Okay. So I have not looked at any of the manuals for any of this stuff, but look down here. I love that they tell you which terminal block to use. Of course, there's asterisks there because you have a choice between spring or screw. But it's right there on the front of the unit. That's awesome. Okay. Terminal block wiring. High-speed counter module. 1 incremental in. 2 24-volt DC in. 4 DC out. And it says this is a hardened module. So that's the H at the end there, the model number. So this will support an extended range in harsher environments. Okay. What else do we have here? This is an analog in2 universal, I believe, isolated. Okay, let's open it up. Okay. Analog input 2, isolated in, current voltage, 234 wire with loop power. Okay. Again, this is another kit. They're all kits because you don't want to have to buy these separately when you're buying a new setup. What do we have here? This is a PFD, so this is just to extend field power to the right-hand side. Okay. What's next? It's like an analog. Let's see what it says here. Analog input module 4N, current voltage 2 wires. Okay. Looks like an analog out. Analog output for output current voltage. Excellent. These are smaller than your average I/O cards too, so latest and greatest in technology. They're also very secure. We'll talk about that more in a bit, but even the backplane is secure. So, you know, there's a trusted module in the NIM. The backplane uses secure communications. This is a PCM. Okay, what is that? Oh, this is a common distribution module. So you can bring all your, you can see the first 8 are 24 volts out. And the next 8 are voltage out, 0 volts out. So that's great. So if you had Need to land some more wires from your 2 or 3 wire sensors? There you go. You have both your 24 volts and your 0 volts. Excellent. What else have we got? Okay. This is a DDO, so discrete digital output. Let's see what it says here. 8 outputs, 24 volts DC. Sourcing, protected, external supply. A lot of different models they sent in, which is great because that means we get to look at them all. And they have a lot of future models coming as well. What I show you here is not, in any stretch of the imagination, everything they have. Okay, so this is just a good sampling of the common modules out today. Field Device Master Module. I/O Link Master, 4 channels. That is awesome. We've covered I/O Link quite a bit. We've had the I/O Link folks on the show. And so having an I/O Link Master is pretty awesome. What do we have here? This is a dummy module. So to reserve a slot, if you an OEM, you have some options that you usually include on some of your machines, but not others. They have a what they call a dummy module. I kind of like the name. Other companies have different names for it, but this just reserves that slot so that, because there's no chassis, right? You can just put this in there and it'll sit there and reserve the spot for another product. Just a note on these not for sale stickers. One of the promises we make all of our sponsors is that any samples we get will never be sold. If 5, 10, 15 years from now, they might be donated to an educational institution, but never sold for profit. We don't want, I know that was been a big problem for vendors in the past and quite honestly for resellers in the past, because people steal stuff off the shelf and then sell it. And that's just a horrible thing to do. But, let's keep on going here. What do we have now? What is this guy? This is the cluster termination I mentioned earlier. Now, you're not going to receive it separate like I did. When you buy the network interface module today, the NIM, this is going to be included with it. So basically, today, with that NIM I showed you, we can get up to 32 slice I/O, edge I/O, NTS modules in one cluster of I/O, okay? And in the future, you'll actually be able to expand that with multiple clusters in what they call an island. So this will be our terminator for our first rack or bank of I/O. So that's good. And now the rest of these things are, well, let's see what this is, a little bit fatter than others. I believe the rest of what we have here is terminal blocks. Okay, these look like labels. Another tip I received from Schneider was that they are working very hard to eliminate all plastic packaging from their products. And so products like this, if you order them today, you won't get them in this plastic bag. So they're eliminating all the extra plastic waste from their packaging. And so I thought I should mention that because you're not going to get the plastic bag when you order these 50 labels. Okay, so let's put that one aside. And then I believe the rest of these are just terminal blocks. So what I'm going to do is I'll just do a time lapse of me opening them all up. Now that I have all the terminal blocks on the modules, I wanted to show you how they physically assemble. So I have a piece of DIN rail here, and what we'll do is we'll go ahead and put all the modules on. And then after that, after we go through the assembly, then what I'll do is I'll do a time lapse wiring up in my trainer. But first, of course, we're always going to start on the leftmost side of the rail is going to be our NIM. Okay, I got the green clips up here. So I'm just going to put the top on first and then go down and lock those in. It's as easy as that. Next, I got the power supply module. Again, I'll put that on here, a little to the right, go down, and then slide it together and lock that green tab. Okay, and that's how easy it is to go through and assemble. It actually goes together very quickly, and I really like it. It feels like it's very firm and on the DIN rail. It feels like the modules are connected firmly. They have a good connection. There's no worry about the electrical connections connecting. They just go right in and seal in. And so you can see over the years, vendors like Schneider have really mastered how to get these I/O modules to connect together. And you can see how fast I'm doing this. I'm just going to put this other power supply here power supply model between the analog and the digital. So I didn't spend a lot of time engineering this order. I'm just putting them in an order I thought would make sense. And if you guys think I'm doing something wrong, let me know. But in any case, just putting everything together here. Okay. And I'm going to put the dummy module at the end and the terminator. So you can see how easy that went together. You can see I got all the locking mechanisms down, so nothing's going to fall out. And just really a good looking cluster of I/O or island of I/O. And yeah, I'm pretty impressed with how it goes together. You can tell this is a modern system because it's very well engineered. So now from here, one more thing I wanted to show you. I wanted to show you how these covers pop off. So I'm just going to flip them all up, and this way I can get right to the wiring. I don't have this much I/O in my trainer. For the training courses I do, this is a lot of I/O. Not for a machine, but for a training course. That would just be tons of lights and buttons and switches and motors. But in any case, they just pop up very easily, and they swing completely out of the way. That's one of the things I appreciate. They don't hang over. They completely swing out of the way, so I can get in there. And these are all the push-in style, which are great. It'll be really fast to wire this up. And these look like test points, which I really love that they have those test points right there on the front. So in any case, that's how they physically go together. Now let's do the time lapse of me wiring up to my trainer here on my right. And while we're watching the wiring, I did want to mention a couple things. First of all, I was a little concerned because these wires are pretty frayed. I've been wiring different demos into them for like 12 years now. But I really had no problems, as you can see here, and all the wires actually fit nicely underneath the plastic hood, so that was good too. And the other thing I wanted to mention was it was very easy to find the wiring diagrams for these modules. So there is a manual for all the digital modules, and in it, it had all the wiring diagrams, and they were listed clearly in the table of contents. So kudos to Schneider. I know some of the vendors I've used over the last year or two, it's very hard to find their wiring diagrams. So I really appreciate that. Not only having easy to understand, model numbers like, NTS DDI for digital DC input, but also having easy to find and readily available wiring diagrams, which are, was just such a pleasant surprise that it made it easy really to wire everything up. Okay, now that the wiring's done, I have to choose a way to assign it its address on the network. And there's a few different ways that, that you can do that. It defaults, you can use the default 1010 address. I don't want to change my computer, so I'm not going to go that route. Also, you can use the USB-C. The address the USB-C is at conflicts with the addresses on my network. So I'm going to avoid that as well. Probably wouldn't conflict with yours, but because I have so many devices in here, I use a Class B. And another option would be to assign it an address based on a DHCP server, but I don't think a lot of you out there are going to have that on every plant floor you visit. So I thought, hey, it has BootP. Rockwell people are used to using BootP for decades now, right, to assign addresses to the PLC parts. So let's go ahead and set it for BootP. So I'm going to go ahead and tweak this in here. Okay. And so now it's set for BootP, and I'm going to go ahead and power it on. I'll be right back. Okay, we can see it booting up. So let's go over to the PC here, and let me open the BootP DHCP tool from Rockwell here, and this is a different PLC. That's not what we're looking for. There it is. This particular one has a MAC address of 000054XYZ. That's the one I want. So let's go ahead and double click on him and give him an address of 192.168.1.220 is what I want to use for this guy. I think that's the next available on my network. And so now that I've set an IP address on the unit, we can attach to its web page and configure it. Now what I could do is I did download the Edge IO NTS configurator, but I thought since the web page was the same really configuration, why not just use it? So we're going to open up my web browser here. I'm going to open up a new tab. I'm going to type in 192.168.1.220, and you're going to see an error here. If it tries to connect with just HTTP without the S, you will get an error. You'll see this, right? So just keep that in mind. It has to be HTTPS. Okay. And so we'll wait for that to reconnect. And I'm going to go advance and proceed. And we will connect to the unit itself. Now, when the unit is brand new, you do have to log in with the default username and password, which is security admin. And the password is AAAA, and that is all in the NIMS manual. Very easy to use. There's actually a separate manual on this web interface itself, which is also very well written. And the first time you log in, of course, you have to give it a new password. And I just have one that I use with vendors so I can keep track of them. Okay, they match, so we're good to go. Change password. All right, and here we are in the configuration. Now, I think the easiest thing to do is, since I have it all set up, I could build it manually, but I got it all set up and I got it connected, so why don't I go ahead and do a scan and create configuration. It'll scan in all the modules I have out there and save me from having to add them all manually. Okay, and here we can see we got the NIM here, the network connection. We have the power supply. We have the digital input. Then we have the digital output. We have this as a passive, but look, it has a red icon next to it. So it's saying, hey, select the digital version. Well, this is an NTS PCM. So let's choose NTS PCM. Okay. We'll keep going. We have the counter module. We have the field bus master. We have, that is actually the IO link. We have a second power supply. This is the PFD. So let's just choose PFD. Okay. And it says all modules looking good. Now I didn't wire in the analog modules. We're going to see those are going to be an error because they don't have their field power, but that's okay. I'm not going to use them in this video. So I'm going to go ahead, choose a project name. And for the project name, I'm going to call this edge_IO_NTS_01. I'm going to copy that too because I'm going to use that later. Okay. So let's create our configuration. Okay, now it's saying, hey, select the module to continue. And so there is my NIM. Let me expand it. And there is everything that's in there. And I thought it was really cool. It does a power calculation for you. And when I saw this low battery, I'm like, is it out of power? Well, you can see when you hover over it, it gives you the information, but you can also click on this drop down and do power consumption. And you can see that I have plenty of bus power. That's not a problem, right? This can do up to 32 modules, so that's good to know. But my field power, you see I'm at 79% from the first power supply module to the second, okay? So I have the bus and field power supply right next to the NIM, and then I have the second one. So I placed it pretty good. So I have lots of expansion on the second one, and I'm not at 100% on the first one. So that's good to know. I love how it does that automatically, so you don't have to go figure that out. So that's good there. Also, I do want to give it a stored address, so I'm going to just double click in here and give it that address. I don't want to keep doing boot P. Okay, and subnet mask. I'm not using any routers or gateways, so I don't need a gateway address. Look at this communications. If I don't change that, I'm not going to change that now, but I should, because I'm going to be using Ethernet IP, but I want to show you because this tricked me. I want to show you about that. You need to change this. If you use an Ethernet IP, you need to change that or you will not be able to create your EDS file, okay? And so I'll leave everything else the same. And I'm going to go up here to Island Setup, okay? And here I need to enable Ethernet IP if I want to use it. So let me go ahead and edit and turn it on and apply the changes. Are you sure you want to do this? Yes, I do. Excellent. Okay, so now I want to go back to Island Management. And if I come here to this drop-down, you see it will not let me do an export EDS, even though I've enabled Ethernet IP. And that's because of what I showed you right here, that the implicit communication protocol is not correct. It needs to be Ethernet IP if I want to create an EDS file. So now that we get that changed, we're ready to look at the memory mapping, okay? And so I want to know where my inputs and outputs are going. Remember, I'm using module 1 for my 16 inputs and modules 3 and 4 for my 10 outputs. So let's go ahead and expand Assembly 101. And if you look here, I can see module 1, 0 through 7 inputs are going to byte 6, okay? And 8 to 15 is going to byte 7. So remember that. Inputs 6 and 7, those are the bytes we need. Now let's take a look at the outputs. Okay, so I have module 3 has 8 outputs. Okay, that's going to 6, okay? And module 4 has 8 outputs, and that's going to 8. So on the inputs, we're looking at 6 and 7. On the outputs, we're looking at 6 and 8, okay? So now we know the memory mapping. All right, so I think I'm done here. I've changed everything I had to change. Let's go ahead. You can see I'm building offline. Let's go ahead and download the configuration to the NIM. Of course, this is the web page for the NIM that I'm connected to, but I'm not doing an online monitor. I'm doing offline configure. So let's download the configuration to the NIM, and this will just take a second. Okay, and it says, hey, you can't do that because you know what? The IP address for the USB port is on the same subnet. That's why I didn't use the USB port because you get that error, right? So in any case, because I'm a class B, they overlap each other. So let me come down here and change that. I'll make him 192.167, okay, to get rid of that issue, okay? And so now let's try it again. It said configuration validated and has been successfully downloaded. Excellent. And you just saw that it said in that message, you'll have to log in again. So let's go ahead and do that. Okay, we're back in. I want to go online. I want to show you those errors with my analog modules, just so you can see it. And so I'm going to expand the NIM. I am online, and look at these errors. Internal field power supply error detected. You know, I didn't wire them up. I'm not using them in this example, so they're there, but they have no power. So that's fine. But I just wanted to let you see what kind of an error you could look at when you're online. And there's a lot of other things in here. There's logs in here. There's also some future features coming out for maintenance, which I think is really cool. I won't go into them now because it's kind of coming in the future. But really love this. It's a very usable built-in web page. You know, a lot of devices have a built-in web page, but you really can't do much with it. Well, this is pretty cool. You can see I configured everything. I read in, and you know what? Let's go ahead and save our configuration too. So let me go back offline and let me save it. Maybe I want to save it to my hard drive and open it in the offline software. So now it's saved. The last thing I want to do in here though is I do want to create my EDS file. You can see it's not grayed out anymore. And so I will export that because I have to have that to add it to Studio 5000. So I'm going to go ahead and export it. I went to my downloads. It's called nim_1. Okay, so we're done setting it up. That was pretty painless, right? As long as you know those couple little things. And so let me go ahead and minimize this. And I have already created a Studio 5000 project. You guys have seen me create hundreds of these over the years, so I didn't think you guys needed to see me do that from scratch. But what I need to do, though, is I need to register that EDS file. So let me open up, you could either do the EDS hardware wizard or the device descriptive file installation tool, but whichever one you choose, you'll see it pop up like this, and then I'm going to do an add. I'm just doing a single file. It's in my downloads. Let me go to downloads. Okay, NIM1. There it is. It's reading it in. Okay. Very good. Next. Do you want to add that? Yes, I do. Yeah, it doesn't have a cool picture, but that's okay. We need it to be functional. So it has that default picture, that default cube, but that's okay. We'll click on Finished. And now when it's done, we will exit and we'll come back to Logix. And now over here on Ethernet, I'm going to right click and I'm going to select New Module. And instead of doing a generic module, I'm going to search for NTS. And there it is. Okay, so let me create this. And it's going to want an IP address, of course. I'm adding remote I/O. The other thing, I have to give it a name. If you know anything about Studio 5000, anything on the network has to have a name. That's why I copied that Edge IO NTS 01 earlier, so I could use that as the name. And then the IP address, of course, I got to put that in there, 192.168.1.220. All right, now you can see more information in here. You can see the read from 101 right to 102. We saw that when we were looking at, words, bytes 6 and 7 and 6 and 8. So that's where that's coming from. You can see the RPI, 10 milliseconds, all that other stuff in there, module info. Well, we're not connected, so we won't see that. And then you can see 1001 and that information there. So we're just ready to hit OK. So let's do it. Okay, and close. Let's go look at our controller tags. Now, I already added some tags in here. Aliases to those controller tags, but here you can see my input data. So these are all my bytes. You can see, what do I have? Up through 44, so 45 bytes. They're all synths, okay? And of course, we're going to be looking at 6 and 7. And then for the outputs, okay, here we want 6 and 8. Okay, there's 6, and there's 8. And again, these are synths or bytes, so you only get 8 bits. All right. And then I'll show you the tags I already created. So I made tags just to match my trainer here. So PB1, PB2, PB3, and so on. You can see I'm going to Edge IO NTS 01, input data 6, 0 through 7. And then when I pick up on the next one, I do 7.0 through 7.7. And then for the outputs, you can see right here, okay, I have some pilot lights. So again, output data 6, 0 through 7. And then remember we said we skipped 7, went to 8. So then I have my second motor and a pilot light here, 8.0, 8.1, okay? And so those all correspond back to these two here, okay? And again, how did I know it was 6 and 7 in and 6 and 8 out? By looking at the memory map. So with that said, I also put in a program to save time where the first, 5 push buttons will turn on the first 5 pilot lights. Again, not using the local I/O, using the Edge IO NTS. So let's go ahead and I'm going to save this as done. Okay, not start. Done. Okay, and yes, I've already done this once. Wanted to make sure everything worked. And now let's go ahead and download I got to give it a path. Communications to active. Okay, let's go out there. And this is the guy I want to download to. Getting ready for some in-person training, so I got all the PLCs on, and let's go ahead and download this new program over whatever's in there. That was the test program to test the test stand. I did find, it's funny, but I did find I made some wiring mistakes when I was wiring up. I'm using a new type of terminal block, and I mixed up a couple wires, but now we are online. We have the program up. We now can test out this program. Let me see if I can make this half screen so I can make the overhead cam half screen here. Okay, let me get rid of this tooltip here. And so now with this here, I should be able to come over here and press my stop buttons. Well, let's see, let's press the stop button first. We can see it's on there. It's on the field. And I know it's hard to see with the overhead cam, but you saw that light come on as well. I'll press the next button. Okay. Let's try some of these. Excellent. And let's go back full screen here to the computer. And let me go to the controller tags and see if I can turn on some of the motors. I have no code writing to the motors, so I should be able to monitor those tags and turn them on. You know what? Let me go back half screen here so we can bring the overhead back up. Okay, let me move this over here. So I'm looking for output M1. Let me just turn that on. Yep. And output this one here. Okay, and what we're seeing here is on the unit itself, the output lights have come on, so I know that I'm controlling it through this device. And of course, if I disconnected the device, all the outputs go off. It's not holding last state. I did not tell it to hold last state because I don't want it in this case. But you know, that kind of proves that we're going through the Modicon Edge IO NTS. And I'll plug it back in, and in a few moments it should pick back up, and when we should see the motors go back on. And when they do, I'll go over to the computer here and I will turn them off. Okay, so just give me a second here. All right, and with that, that's how easy it is to use the Modicon Edge IO NTS with a Rockwell ControlLogix or CompactLogix. And I think the key there is a couple things that makes this product, I mean, aside from the hardware niceties that we saw at the very beginning of the video, a couple of things that make this product easy to use is I think wiring was very easy. The wiring diagrams were very easy to access, right? They weren't hard to find. There's one manual that has all the digital modules in it, and the wiring diagrams are all in there. The other thing I think was the built-in configurator right on the NIM, right? So I was able to just use boot P to give it an address. And then I was just get in there and I was able to set all those settings. You walked through it with me. There's a couple of things you have to know. Just turning on Ethernet IP is not enough. If you're going to use it on Ethernet IP, you also have to make the primary field bus Ethernet IP. And the other thing is, if you're probably not, but if you had 192.168 as a Class B network in your building, then you'll go have to change the IP address for the USB port. But in any case, that configurator I thought was very easy to use, very intuitive. It didn't take me very long to get the setup running. You just, doing the scan, like if you have your modules connected, scanning them in, that's great. Now again, there's an offline configurator if you don't have a model. If you don't have one of these units, you can do it all in a separate software package that's free. But since I had the NIM, I figured I'd connect to it and scan in what was already connected. And I love that. It just did that all for me. I love that it calculated the power for me too, because you only can have so much power per bank of I/O, right? So you need a new power supply every so often based on how many I/Os you're going to have, for both bus and field power. And so that's something you have to consider. And I just thought it was very intuitive, except for those couple little things I showed you that I ran into, first time using it. And as far as bringing that EDS file into Studio 5000, that seemed very intuitive, right? And so I think a lot of people are using that feature, but they're not promoting it. But by bringing that, saving that EDS file, saving it out of the configurator, bringing it in the Studio 5000, everything was laid out. The biggest thing I think is I would love to see the configurator describe each of those points. Wouldn't that be cool? Because I had to, prior to the show, I made a bunch of tags so I knew what was what. Finding out that it was input 6 and 7 and output 6 and 8 was pretty easy, right? Looking at the memory map. But, still, it's just a bunch of bits. So it's nice to have a description there, what they are. And, maybe in the future, Schneider will add that where it will tell you module 1, input 0, input 1, input 2. But until then, it wasn't too difficult to throw all those aliases in there, or you could throw descriptions in if you prefer. I liked having the aliases in because I could put those in even when I in the stop file. You can't put descriptions in if the actual addresses don't exist, right? So with that, I would love to know what you guys think. Did you think this was easy? Now again, I know if you're using Modicon, this is probably going to be your choice of I/O. But if you're a Modicon user who has to occasionally do maybe Rockwell, then you potentially could keep your I/O, right? Because it's multi-field bus, and use Rockwell and Modicon PLCs or PACs with the same I/O. And so being that this is new and it's designed from the scratch, with the secure TPM module inside the NIM, with secure communications on the backplane, and then security in the modules themselves. It really seems to be like a next generation I/O platform designed for security and ease of use too. I got to say that, from picking out the modules to actually programming it. It all seemed pretty easy. But I'd like to know what you guys think, and I also want to thank Schneider for sponsoring this episode. Not only did they send me in this rack of I/O, right? And there's so much that he had left to try. The counter modules, which have onboard outputs, so you can say, hey, when it gets to a specific count or rate or whatever, it can fire the outputs like within under 20 microseconds. That is pretty cool. And then the I/O Link, we just did a bunch of I/O Link, and I/O Link, I don't have any Schneider I/O Link devices, but just a lot there that for future videos that we hopefully will get the test and trial as time goes on. But again, I want to thank Schneider Electric for sponsoring this episode to make it ad-free and for sending in the hardware as well. And I want to thank you for watching this episode. Love to hear your comments. Leave in the description. I'll have all kinds of helpful links in the description as well. And with that, I just want to wish you all good health and happiness. And until next time, my friends, peace.